We shall see. Yeah. All right. So, what do you guys think of when you hear the word overlapping? On top of the other, overlaps. Yeah. Very good. So, overlapping triangles are triangles that have a common side or a common angle. They're going to overlap each other today. A lot of times you can simplify your work with overlapping triangles if you separate them and redraw them. So we're working with overlapping triangles today. The first thing we want you to be able to do is identify the common parts, the angles or sides that they have in common. In a little bit I will. Okay. So let's take a look at our first example. Triangle ABC and triangle DCB. And we would like to identify all the common angles or sides. So as we said on the first slide, a lot of times it's easiest Okay. So as we said, the first thing and easiest thing to do is to redraw the triangles. So here's triangle ABC. And triangle DCB. Do they have any angles or sides in common? What do you think? What do you think common would mean? Not necessarily equal, but be the same. Yeah, a side that they both share. BC is definitely a common side. Do they have any common angles? DCB and ABC, are they the same angle? The only side they have in common is BC. I don't know if it helps. I don't know if highlighting it would help. Like here's triangle A. Yeah, that worked really well. Thank you. Triangle ABC. And triangle DCB. If I had colors, that would be good, but unfortunately, what side did I copy twice? BC. That's the common side. Does that make sense? Okay. Okay. Okay, what about triangle EFG and triangle HGF? What do they have in common? Dalen says they have side FG in common. So EFG, ooh, maybe this will work. And HG, whoa. It's like really hard to see from back here. HGF. Is that all they have in common? Yeah. Okay. Awesome. How are we feeling so far? That's what we like to hear. See if this one's easy. Respond with your clickers in the next 90 seconds. What is the common angle in the triangles below? Triangle JML and triangle NKL. When you see yours turn dark, your number turn dark blue, that means you're in. Your response is in. Is everybody content with your responses? Okay. Not bad. 83% of us are correct. They do share side L, or excuse me, angle L. So again, it might be easiest if you redraw the triangles. Triangle. Where'd my pen go? I can't see that color. I need to get my eyes checked. Okay, triangle JML. And triangle NKL. They both use angle L. Okay. All right. Oh, another clicker question. What's the common side between these two triangles? Triangle GEH and triangle FEH. GEH and FEH. There is a lot of triangles. Let's see. GEH and FEH. What is the common side in the triangles below? What's that? What line? What line are you talking about? FG? Basically, it's a trapezoid with connecting diagonals. So what side do they have in common? What side's both red and purple? Okay. Improved our percentage. 22 of you are correct. It is side EH. It is side EH. Good. How are we doing so far, guys? Dalen says easy. Does everybody concur? Okay. All right. Let's work on a proof. Okay. Let's complete this two-column proof. Given the measure of FEH equals the measure of GFE, which equals 90, given that EH is congruent to FG, we have to prove that HF is congruent to EG. So as you can see, as with all proofs, we always start off with the given. And notice the last line of the proof is what we were asked to prove. Now notice here at reason 4, what does SAS stand for? So if you're using side angle side, then you must be saying what is congruent to what. What shapes are congruent for side angle side? Starts with a T. Triangles. Correct. Okay. Well, it looks like there's 4 things to fill in, guys. Anybody want to take a shot at filling in either reason 2 or 3 or 5, or 2 is given. How's 2 given? Okay. I can live with that. They're both 90. Okay. Anybody got a shot for 3? Why would EF be congruent to FE? They're the same side, so that's the reflexive property. Huh. Now it says we're using side angle side. Can you guys see a side angle side anywhere in here? There you go. Triangle HEF is side angle side. What triangle would it be congruent to? Nope. Number 2, they're both 90. Sorry. Plus, all right angles are congruent. FEH, that's the same as HEF. What other triangle? I agree with you guys. HEF, because you got side, the right angle, and the side.
Oh, EFG.
There you go. GFE. Good deal. Hey, we just proved that 2 triangles are congruent to each other. So if 2 triangles are congruent, what can we say about all the parts? Corresponding parts of congruent triangles are congruent. By the way, recall from yesterday, HF and EG are the what of these 2 right triangles? The hypotenuse. Correct. Awesome. We just did the proof. Okay. Remember, whenever you name 2 things that are the same as congruent to each other, it's the reflexive property. It's got to be the exact same. All right. Oh, that's it. CPC